Transformer. What is a transformer? A transformer is a device which is used to transform an electric power of what? Of one circuit into another circuit in the same frequency. So let's draw the transformer and see. So this is a transformer, and therefore we have the magnetic core here. We have magnetic core, and this is what? This is a primary side, and this is a secondary side, and also this is what? This is the input, and this is what? This is the output of a transformer. Let's say this is what? This is a magnetic core. This is a magnetic core. This is the output, this is the input. So this is a diagram of what? Of transformer. But you have to take note that we have step up. We have step up transformer, and we have what? We have step down transformer. So what is step up transformer? Step up transformer is a transformer whereby the number of turns of secondary is greater than the what? The number of what? Turns in primary. This is step what? This is step up transformer. Step up transformer. A transformer is said to be step up when the number of turns of secondary is greater than the number of turns of what? Of primary. But when number of turns of secondary is less than the number of turns of what? Primary. It means when number of primary is higher than the number of what? Secondary. So that's what? That's step down. And this is what? This is step up. Step up transformer. So how can let me draw this step up and step down transformer. So let's draw transformer. So let's see this. So as you can see, this is the number of secondary turns is greater than the number of what? Primary turns. So let's say this is what? This is the number of what? Number of primary turns. Let's select this. So as you can see, the number of what? Of this is a secondary what? This is we have primary winding, we have secondary winding, and therefore we have primary turns, we have secondary turns. So these are the turns. These are the turns, and this is turn. As you can see, we have how many turns? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 1, 2, 3, 4. So therefore, the number of these turns is greater than this. So therefore, this transformer is said to be what? Is said to be step up. But when it is step down, so this is a step down transformer, whereby the number of what? Let's say we have this. Let's say we only have this. So as you can see, this is what? This is a step down transformer because the number of the primary side, the number of turns of the primary side is greater than the number of what? of the secondary side. The number of turns of primary is greater than the number of turns of secondary side. So this is what? This is a step down transformer. So there is a transformer that we call there is a co-type transformer. There is a co-type transformer and there is a what? There is a shell type transformer. The difference between this transformer is that this shell type transformer, it has what? It has double magnetic circuit, but why this co-type transformer, it has single magnetic circuit. What I mean by that? Let's say to draw the co-type transformer. So this is, let's say, the co-type transformer. Let's say the co-type transformer. So this is a co-type transformer because it has only one magnetic circuit. But why the shell type transformer, it has what? It has two magnetic circuits. So this is what we call the shell type transformer. It has two magnetic circuit. The magnetic circuit is not the same. It has single magnetic circuit. It has double magnetic circuit, and also the limbs are what? The limbs of the transformer and the limbs of the transformer are what? Are not the same. So therefore, this is all on the introduction to transformers. We have what? Transformer circuit, step up and step down transformer, and we have what? We have the co-type transformer. This is co-type transformer, and this is what? This is the shell type what? Shell type transformer. So the next thing that we're going to do, we have to see some importance formula of what? Of transformer. So here are some importance formulas under the transformer. We have the EMF equation of transformer. So you can be able to find what? If you are asked to find the EMF, 4.44 frequency multiplied by the number of turns. This E stands for the induced, and this F, which is the frequency, and N is the number of turns, and this is what? This is the maximum flux. So under this we have maybe we might ask to calculate for primary and secondary. If you're asked to calculate for the primary and secondary, so you can use what? The number of the EMF that you are given for primary, you will insert it here. Maybe you are asked to find the frequency, but you are given this. But if you are not given this, but you are asked to find this for primary, so you can use the number of turns of what primary that you are given, and also for the secondary. So after then, for the turn ratio, if we take a look for the turn ratio, if we are going to find the turn ratio of a transformer, we have to say the number of what? Primary divided by the what? Number of secondary. So we have the transformer relation, which is the X formula, which is V2 by V1, E2 by E1, N2 by N1, I1 by what? I1 by I2. So therefore we have what? We have the current ratio. If maybe a question says you are asked to find the primary current, so you can use this relation to find what? To find the primary current by cross multiply, and you have what? You have N1 I1, which is equals to what? N2 what? N2 I2. So you can do that. So the next thing that you're going to do, we have the flux what? We have the flux formula. The flux formula, if you are asked to find the what? The flux, so you can be able to make the flux formula of the formula from what? From that formula that we did. So the next thing that you are going to do, which is the frequency, also if you have to find the frequency, and we have the power in ideal X format transformer. The power input is same thing as power output as what? We all know that the power input is same thing as B1 I1. So power is same thing as what? V multiplied by I. Power is same thing as IB. So therefore IB1, BI and I1, and also B2 and I2 are what? They are all the same, but the difference is what? Input and what? And output. And also we have the efficiency, the output over the input multiplied by 100. You get the, sorry, this is 100. You will get what? You will get the percentage of what? Of the efficiency. And also another efficiency, if you are not given the output, or let me say it is all the same, because we are talking about what? We are talking about the input over what? Over the, we are talking about the output over what? Over the input power. The input over what? Over the output power, which says, yeah, which says that the V2I2 multiplied by the cos psi 2 divided by what? V2I2 plus cos what? Cos psi 2 plus what? Plus the power of the iron or colors plus what? Plus the copper loss. So we have the copper loss, which is what? I square multiplied by R, and also the primary copper loss, which is what? I square by what? By R. So these are the most important formulas that you may use in what's in transformer. So make sure you write them down, because they are what? They are very important. And also we have another formulas. We have the secondary copper loss, which the secondary copper loss is the same thing as I2 secondary but square it multiplied by R. And we have the total copper loss, and also we have what? The total copper loss, which is for the copper loss of primary plus copper loss of secondary. And we have the core iron loss, the core iron loss, which is the core iron is the same thing as what? The high statistics loss plus what? Plus the eddy current what? Loss. If you are asked to find either the high statistics, you can make the subject of the formula. So we have the voltage regulation. Voltage regulation says that the no load voltage minus what? Minus the full load voltage divided by the no load voltage multiplied by what? Multiplied by 100. And we have the R equivalent. The equivalent resistance refers to primary. R equivalent is something as R1 plus R2 prime, and R2 prime is the same thing as what? N1 over N2 squared. It means I can say it's the same thing as what? R2 what? Multiplied by what? R square. This means the turn ratio. And also we have the equivalent reactance x1 plus x2 prime. X2 is the same thing as what? X2 multiplied by what? The R, which is what? Which is the turn ratio squared. And the impedance transformation. The impedance transformation, which is Z, is the same thing also as Z multiplied by what? ZR what? ZR squared. And we have the transformer EMF pattern. Pattern, it means we're excluding the turn, and which is what? The transformer. The EMF what? Pattern, which is ET 4.44 flux. Okay, maximum what? Maximum flux, but there is no number of turns. We have the full load transformer. The full load, there is full load and there is no load. So this is what? This is full load transformer, which is output over the output plus the loss. Output over the output plus loss multiplied by what? Multiplied by 100. And also we have transformer output, which is equal to the power output, which is the same thing as what? V2 what? I2 cos what? Cos psi. I think this formula can also be used to find the power factor. So we have the no load current component. No load current component, if you will recall, but I will not explain that in this video. We have what? We have something like this, and we have something like this. This is the working current. This is the I what? The magnetizing current. This is the I naught, and this is what? This is the what? This is a psi. So as you can see, the component of this I naught, it has two component current, which are this. We have this and this. So therefore we say the I naught is the same thing as what? This and this. By Pythagoras theorem, I will say the I naught square, it is equals to I W squared plus what? Plus I magnetizing squared. So I have to take the root of both sides. We'll go with this. At the end, I naught will now be equals to what? I W squared plus what? I magnetizing squared. And therefore you can be able to find the I magnetizing if you use what? the horizontal and what, and the vertical. Horizontal, which is cos, vertical, which is sine. So therefore you can find the IW and what's IM, which is a magnetizing current. So this is all I have for you for this video. Don't forget to subscribe to this YouTube channel. Thanks you for watching. Have a nice day.